Okay, this lecture is about propositional logic. Propositional logic is the simplest of the logics that we'll be studying. And we'll start with a cartoon from Dilbert. It's about a guy who shows a cartoon before giving a presentation. Okay, what are propositions? Propositions are statements or sentences that we say about the world. For example, it is raining is a statement. The wall is yellow. This is Ram. I am Pi. 2 plus 2 equal to 3. 2 greater than 3. They are statements. They just say something about the world or about somebody or something. Now, are they true or false? Each statement in a given situation in a given world is either true or false. It cannot be unknown. You may not know it, but it's true or false. It depends on the truth of the statement depends on the location and the speaker and the time and the situation. For example, this is Ram depends on whether Ram is there or not. I am Pi depends on who says it. But something like 2 plus 2 equal to 3 is false in every situation, no matter who says it. What about 2 plus 2 equal to x? Anyway, we'll get to that later. But before that, let's look at more examples. So something like 1 equal to 1 is always true. That's called a tautology. And something like 1 equal to 2 is false. It's called a contradiction or invalid. Many of these words come from Latin, where logic was studied 2000 years ago. So it's not a new topic or something, it's well known. And only thing, the symbolism is new, the symbols. So when you have statements, you can join them together and connect them together and make larger statements. So your propositions, you connect them with or, and, not, if, only if. So these are the 4-5 statements that operators you can use to connect statements together and make larger statements. English has a lot more operators or connectives like but, therefore, implies, so, because, unless. We'll look at a few of them to see what they mean logically. Okay, so real life English is more complicated than simple logic, and we'll see examples as we go along. So or is the simplest of the connectives. It connects two sentences, at least one of which must be true. For example, it is raining or it is sunny. This whole thing is true if at least one of them is true. Either it's raining or sunny or both, the whole statement is true. 1 equal to 2 or x equal to 2 or x equal to 3 or x equal to 4 is a long statement. It has multiple ors in it. And it is true as long as at least one of them is true. We'll see how to parse the sentence later on. And let's look at the notation we are using. So notation comes from print and olden days before computers, when the symbols were limited amount of symbols were there. So the T was reused upside down to mean false. So first of all, we'll use A, B, C, D as propositions to stand for any proposition, and then we use 1, which is the same as true, or T, or top, and then the opposite of 1 is 0, which is false, F, or bottom, upside down T, or contradiction. And the and is a conjunction, and it is ampersand sign, and also upside down V is used, because in olden days you didn't have too many characters set, and you invent new characters just by moving the typeface around, so just rotating it upside down. Or is the bar or the pipe, it's also known as disjunction operator, and use the operator the symbol V. Not we use on a computer in C programming the bang or the exclamation mark, or the tilde in some languages for bit operations, and an L rotated sideways and flipped, that means not. And then we can also prefix the equal to sign with the bang to mean not equal to. This reads as A not equal to B, and then use double equal to mean A equal to is same as B. And equal has another meaning, a single operator, so we'll look at that later when you assignment, but we're not looking at right now assignments, we're just looking at logical connectors. And then there's a triple equal to, that means A is equivalent to B, that means, and you read as if and only if A is true, if and only if B is true, and vice versa. And then there's the implies operator, the arrow, that means A implies B, that means if A is true then B is true. And you can look at all in Wikipedia if you have more questions. and then we make a truth table. So for example, operator OR connects A or B is connected. The truth value of A or B depends on the value of A and B only and nothing else. So if A and B are known, you can decide what is A or B. And A or B is false if and only if both A and B are false. If at least one of them is true, A or B is true. Okay. And what are the properties of the OR operator or the connective? It's commutative. That means A or B is same as B or A for any proposition AB. Okay. And A combined with true is always true, and it doesn't matter which order you write it. And false combined with or A is always the value of A, because false you don't have to consider. And that's the second operator is the AND operator. AND connects two sentences. Both of them must be true for the whole sentence to be true. For example, it is raining and the road is wet. This is made up of two propositions connected by AND. We can join as many ANDs as we want in a sentence. 5 greater than 1 and 5 greater than 2 and so on. And all of them must be true for the whole sentence to be true. And the truth table of AND is similar to the table for OR, except that A and B is true if both, only if both are true. If one of them is false, the whole thing is false. And similarly, the properties of AND are, it is commutative. A and B same as B and A. And A and true is same as the value of A. True basically just you don't need to consider. And if anything is false with AND is always false with A. Okay. So now the question is, can you give example of a non-commutative operator? Well, think about it. Non-commutative means A operator B is not same as B operator A. So for example, we have the answer 1 divided by 2 is not the same as 2 divided by 1. So division is not commutative. Okay, so we'll continue and then after the break.